Hey everyone, let's get started with today's session. So, today we are going to cover Introduction to Machine Learning. So, in this course, so far we have discussed NumPy, Pandas, and now we are going to introduce ourselves to machine learning. So, first of all, these are very commonly used words and often they confuse a lot of people. Data science, artificial intelligence, machine learning. So, these are something that confuses a lot of people. And all these three techniques work closely together and hence are sometimes confused as the main thing. However, one must not feel that these terms are kind of the same. They are actually not the same. They have different meanings and they represent different things. Obviously they are related, but they don't mean the same thing. So talking about first, data science. So data science is kind of a broader field. Let me show it to you. So data science is a process in which huge volumes of raw data is analyzed and processed to extract meaningful information, to use it for various research and business purposes. It is a long process that starts from collecting the raw data. The data can be structured or unstructured. So what is exactly data science? It's the process of extracting meaningful and useful insights, or you can say information, from huge volume of raw data to solve real world problems. That's what data science is. It's a broader concept, right? Now moving on to what machine learning is. Okay, first let me talk about artificial intelligence. So artificial intelligence is basically one of the many disciplines of computer science. The main aim of it is to make machines think like humans, to do some task or make decisions based on the data that's provided. So as I told, data science is a broad concept, and then artificial intelligence is this. So basically data science and artificial intelligence are a bit related. They are a bit related, but data science is a broader concept and artificial intelligence means what? It means that we are making machines think like humans so that they can make decisions based on the data that we are providing them. And AI has been growing exponentially in the past decade. Right now, you also hear those words like Chat GPT, BART, these are all based on AI, right? So it has already been touching our lives in ways that you might not even notice, but now you're noticing them with all these buzzwords. For example, every time you go on Google search, some kind of AI is being used to show you the best results. Similarly, ChatGPT, it's a form of AI. Similarly, BART, again, it's a form of AI. So AI is actually affecting our lives in every possible way. Even when you ask Siri or Alexa a question, natural language processing and speech recognition is being used. And the best examples of AI could also be robots and self-driving cars like Waymo. So artificial intelligence is used for lots and lots of things, and right now it's the buzzword in market because of Chat GPT and BART. Now, what is machine learning? Machine learning is basically a subset of AI, and the aim of machine learning is to keep learning to help the machine think and act like humans. So it's a subset of AI. Basically, we are using data to make our machines learn so that they don't need to be explicitly programmed. Okay, so let me make machine learning here. Machine learning would be like this. Okay, it's going to be like this. So machine learning is a subset of AI. So now let's revise the difference between data science, AI, and ML. So data science focuses on collecting, managing, processing, and interpreting to draw insights from the big data so that we can perform decisions or make decisions. Um, Artificial intelligence and machine learnings are two of the technologies used within data science to help in the decision making process. Machine learning develops algorithms to analyze data, to learn from it to predict trends. So basically in machine learning, what we are doing is we are helping the machines learn from the data so that we don't have to explicitly program them. Okay? And AI uses this data and predictions for decision making. That's pretty much uh, data science, AI, ML. So data science, it's a broader concept. Machine learning is a subset of AI. And what is exactly AI? AI essentially means that we are making the machines think like humans do to make decisions based on the data that we are providing them. Okay. Now, let's move ahead to machine learning. We already discussed data science, machine learning, AI. So, machine learning is basically enabling the computers to learn from the data. Basically, we want the machines or the computers to learn. So, machine learning means machines learn from the data without we having to explicitly program them. We don't tell them what they need to do. They are going to learn from the data, they are going to improve themselves, and then perform some tasks for us. Now, these are two things, data and information. So, what you provide to the machines as the input is basically the data. And what you get out is the information. So, data is basically the unprocessed raw facts and figures, and it's the input, whereas information is the output. Okay, it's the output, and this information, since it's the output, it carries logical meaning, whereas data does not carry logical meaning. And information, since it's the output, it will obviously depend on the input, which is the data. So information depends on the data, whereas the data does not depend on the information, because input won't depend on the output, right? Output is going to depend on the input. So data and information are also related, as data science, machine learning, and AI were related. Similarly, data and information are also related, but they are different. So data is used as the input for the computer system, whereas information is the output. Data is unprocessed raw facts and figures, whereas information is processed data. Data does not depend on information, whereas information depends on data. Data won't carry any logical meaning, whereas information will have the logical meaning. Data is the input, whereas information is the end product or the output. Now, machine learning is used in lots and lots of places. It is used to make predictions, like make the predictions for temperature, like what would be the temperature tomorrow, make stock market predictions. So machine learning is used to make lots and lots of predictions. Now it is also used to detect images, objects, activities in real world, in real time, or in videos. Machine learning is also used to translate the words that we speak into the captions or the text. Machine learning is used in every industry, and so it's used in the biomedical industry also. One of the examples would be to recognize the cancerous tissue. So does a person have cancer or he does not have cancer? Now it's also used in the finance industry. So right now machine learning, AI is being used everywhere. In all the fields that you see all around, machine learning or AI would be used in some way or the other. So it's a field which is really growing. And there are lots and lots of opportunities and jobs in this industry. Okay, that was pretty much the overview of machine learning, and also we understood where machine learning is used, and the answer is pretty much everywhere. But now let's go a bit technical and try to understand the different types of machine learning. So today we are going to discuss the words that we are going to use throughout in the course. So machine learning has three categories. First is the supervised learning, then we have unsupervised learning, and the last one is reinforcement learning. We are going to deal with all of them, and in this course we are going to focus mostly on supervised and unsupervised learning. So first of all, let's discuss what supervised learning is. Let's try to understand this with help of a data set. Let's create a small data set. Let's have the placement data set where we have the student roll number, the name of the student, his or her 10th marks, 12th marks. Then there was a exam conducted, employability test conducted by the college, and what's the employability test percentage. Then the next is what is their CGPA. then what is the grade they got in communication skills, what is the grade they got in interpersonal skills, and finally whether they are placed or not. So this would be a yes or no. So let's talk about some students here. So this is the data, this is the historical data that we have for the seniors. So let's say serial number is 24, the name is Ria, 10th marks are 75%, 12th is 84, employability test percentages 58, CGPA is out of 10, which is let's say 8.9, communication skills grade is a A, interpersonal skills is a B, and Ria is placed. Then let's move to the next one. The serial number is 583, the name is Shrey, 10th marks are 95, 12th marks are 48, employability test percentage is 75, CGPA is 7.4, communication skills is a B, interpersonal skills is also a B, and the person is placed. Let's talk about one more example, one more student, not example. 111, the name is, let's say, Ajay, 10th marks are 99, 12th marks are 92, employability test percentage 48, CGPA 7.5, communication skills is a C, interpersonal skills is a B, and the person is not placed. So this is the data that we have. Okay. Now, in this way, we have lots and lots of records. We have, let's say, 100 students. So basically, these are the seniors. These are the students who have already sat for placement, and we know their placement status. Now, basically, based on this historical data of the 100 students that we have, now for the new students who will be sitting for placements, that is, their placements are yet not done, based on the historical data that we have of these past 100 students, and for the new students, we'll obviously know their serial number, 10, name, 10th, 12th, employability test percentage, CGPA, communication skills grade, and interpersonal skill grade. So we know all these for the new students also, but we don't know their placement status because they have not sat for placements yet. So for the past data that we have of the 100 students, basically those students who have already sat for placements. So this data basically has Y and has X. X basically means all these attributes. Now, based on these attributes, let me call them as X, based on all these attributes, attributes means columns. So all the columns can be called as features or attributes, and the records will be called as objects. What are records? Records are rows. So row, let me write it, row is equals to record is equals to object, column is equals to feature is equals to attribute. Okay, so basically this is a object, this is a object or a row or a record, and serial number is a column or a feature or an attribute. So let's say this is X, this entire thing, these serial number, name, 10th, 12th, and so on, all are said as X, and placement status is denoted by a Y. So basically, what are we trying to predict? We are trying to predict the placement status of the new students. Those students will be sitting for placements, but for them, we already know their serial number, name, 10th, 12th, employability test percentage, CGPA, communication skills, and interpersonal skills. So basically, how does our data look like? Our data looks like X and Y is the target which we are trying to predict based on the X. So X is basically the attribute which is going to affect our Y, and Y is the dependent attribute that it's depend on X. So all these, serial number, name, 10th, 12th, all of them are independent attributes, whereas the placement status is a dependent attribute which depends on all these independent attributes. And our aim in this situation is to predict whether the person will be placed, whether the student will be placed or unplaced. That is the new student that comes in. And we already have the data of 100 students. We know what are the independent attributes. We also know the placement status. For any new student that comes in, we just know the X. For them, we have to figure out the Y. Okay. So let's say this is the data of our 100 students for which our X and Y is already known. That is, it's the historical data, the data of our past students. We divide it into two parts, training data and testing data. So training data will be used to build the model, to train the model, and testing data will be used to evaluate the model. First of all, one more thing, when we have X and Y, that is we have a target which depends on our X, which depends on the independent attributes, such type of data is called labeled data. Label data. What does label data means? Label data means that we have input attributes and we have an output attribute also. That means we have a Y, we have a target which depends on the independent attributes. So this type of data is called label data, where we have X and Y. This is called label data, right? And supervised learning deals with label data only. So in supervised learning, we have a target to predict. Okay. Now, what exactly happens in supervised learning? So in supervised learning, we divide the data, the historical data, that is the data that we have for all the past students, we divide it into two parts, training and testing. Training data would be a major chunk and testing would be the minor chunk. So basically out of 100 records, we can have 70% data going to training and 30% data going to testing. So 70% is training and 30% is testing. And this process of splitting the data into training and testing is called holdout method. So now what we have done is we have divided the data into training and testing. So let me call this as X train, because this is the part of X, that is the independent attributes, and it's a part of training data also, right? This is Y train similarly. Also here we have multiple independent attributes, right? I'm just denoting it by X. It does not mean that there is only one independent attribute. There are multiple independent attributes. Then here we have X test and this is the Y test. Okay. Let me erase this. So we have already divided the data into training and testing, and this is done randomly. So any record can go to training or it can go to testing. So randomly 70% of the records would go to training data and the left ones, the 30% are going to go to testing. It's up to you if you want to change the percentage. Like, it's not that you only have to have 70% training and 30% testing. You can have 80, 20, 60, 40, it's up to you. But it's just that the bigger piece has to be training data, because you need more data to build the model, because you need more data to actually build the model or train the model, and less data to evaluate, right? So let's say we have our computer here. We are giving X train and Y train, that is we are providing the training data, and we are saying, hey, this is the data, based on this build a model for me. Obviously I will tell the model also, I want to build a linear regression model or a logistic regression model or any model that I want to build. So I'll give the model name as well. Okay, model name, and then I will say that, hey, build this model for me based on this data, and then a model will be built for you based on the data that you provide. So you are already providing the inputs as well and the outputs also. So now the machine will figure out how can Y be figured out from the X that you are providing. So a model will be built. Now once this model is built, you provide X test to it, only X test. And now you say to the model, since you have already learned from the data, from the training data, make predictions for X test. And it will make the predictions Y pred. Let's say Y pred. Now we already have the actual answers of X test with us, which is Y test. And we have also got the predictions from the model, which is Y pred. Now we can compare Y test and Y pred. We can compare these two and figure out if our model is giving us decent results or not. Our model will give us good results when our Y test is very close to Y pred. If it is not, then our model is not doing good, because this is something that actual values are, but this is the prediction that is made by the model. Our model should be as close to the actual values. So if these two are similar, then our model is doing good. If it is not, then our model is not doing good, and we need to change the model or train it again, or make it better in some way. So this is what happens in supervised learning. So in supervised learning, essentially, we work with the label data. That is, we have independent attributes and one target attribute. The target attribute depends on the independent attributes, and this is called label data. That is, we have X and Y both. Now in supervised learning, what do is we divide the data into two pieces: training and testing. The split of the data randomly into training and testing, where training is the bigger chunk, is called the holdout method. And then we provide the training data to our machines to build the model for us. Once the model is built, we provide the X test to our model, the newly built model, and we say that, hey, make the predictions for these X test. And then we get the Y pred, and we compare it with the Y test. So if we take this example, this one, let's see this example and understand it once more so that you have better clarity. One second, I'll rub this portion off. So if you see, let's say randomly this goes to training data and this also goes to training data. So what we are doing is we are having 66.67% data in training and 33.33% data in testing. So 2/3 of is training and 1/3 is testing. So now this and this both are going to be a part of training data. So what do we say is, let's say we have to build a model M, and we are telling the machine that, hey, you have to build the model M, and you provide basically this record and this record. So you provide 24, RIA, 75, 84, 58, 88.9, A, B. This is one of the record. We are only taking the independent attributes, and the second one is 111, Ajay, 99, 92, 48, 7.5, C, B, right? So this is basically the X string, right? This is the X string. We are not providing the Y string. So these two records are basically the X string, only the independent attributes. So this thing and this thing are basically your X string, right? So you provide the X string. Then you also provide this and this, yes and no, which is going to be your Y string. Now your model will be built. So you have the model. Now to your model, you are going to give 583, Shrey, 95, 48, 75, 7.4, B, B. And then based on this, you will say that, hey, this is the data. Tell me whether the student with these details will be placed or not. And let's say your model gives a yes. Now this is your Y prediction. This is your Y test, right? Now you have to compare. Is your Y pred and Y test the same? Yes, it is the same. So our model is probably doing the right thing for us. But if they are different, then our model is not doing the right thing. Now this is, in very simple terms, I've told you what supervised learning is. But I would like to also mention a few more details. So you can only provide numbers to your model. That is this B, Shrey, Ajay, Ria, all this cannot be provided. You only can provide numbers. So all these other things, all these columns which are not numbers, that is, they're non-numerical, they have to be converted into numbers first. And how do we do that? We are going to discuss this discuss this as a part of data pre-processing. The second thing is, that you don't want your y test and your y prediction to be exactly the same. Obviously, if it is the same, it's the ideal condition, but generally it does not happen because there will be lot of testing points. Here we just had one testing point and two training points. Ideally, there will be lots and lots of training points, say millions of training points, and even you can have huge testing points also, many testing points. So all y test and y predictions cannot match exactly. So you have to have some evaluation metrics to figure out what, like how similar your y test and y predictions are. So basically, to evaluate the model, we have evaluation metrics, and they are going to be different for different models. They're going to be different for different models. So basically, our evaluation metrics will decide whether our model is good or not. Now, one more thing. Supervised learning has two categories. One category is called classification and the other is called regression. The only difference, obviously there's a lot of difference, basically for different algorithms there are different models. So for classification we'll have different models, and for regression also we'll have different models. But the main difference is, in classification we are predicting a categorical variable. What does that mean? That we are predicting a variable which has some fixed number of categories only. So if you see, the placement status is yes or no. It cannot be anything else. We already know beforehand that these are the two possible answers only. So in classification, we have some fixed number of categories to predict. It's not that they can only be two, they can be multiple also. For example, let's say we are predicting the grade. Grade could be A, B, C, D or E. So in classification, we have some fixed number of categories only in the target attribute. So in classification, our target attribute is a categorical variable, that is, it has fixed number of categories. In regression example, instead of placement status, if we had something called salary. Now salary could be 0, 1 lakh, 2 lakh, 3 lakh, 10 lakh, 15 lakhs, 20 lakhs and so on. So in regression, essentially what happens is, we have a target which is a continuous variable, which means that it could be anything. It does not have some fixed number of categories. The salary could be anything. 5 lakhs, 5.1 lakh, 5.1333 lakh, 5.133.25 lakh, it could be anything. So salary is basically a continuous variable, and if our target is a continuous variable, it is a regression problem. If our target is a categorical variable, it's a classification problem. Okay, so that's pretty much about supervised learning. So let's read a bit on supervised learning. The machine learning algorithm is trained on labeled data. Labeled data essentially means we have X and Y both. When training a supervised learning algorithm, the training data will consist of inputs, that is X, paired with the correct outputs, that is the Y. For example, if you see here, we basically are telling our machine to learn. That is, we are telling that, hey, this is the mail, this is spam, this is the mail, this is not spam. So we are giving our X and Y both. We are giving X train and Y train both. Now for the X test or the new mail, we are telling that, hey, now the model is built on this training data. Now for the testing data, please give me the prediction whether this new mail that is coming, it is spam or not spam. And then I'll compare it with the actual result. Only if my model turns out to be very good, that is, it's giving good predictions on the testing data, then only it will be used for the new data for which my Y is unknown. So even here, if your model was turning out to be good for the testing data, that is, your Y test and Y predictions were very close to each other. Now for the new students who have not sat for placements and they are new, and for them we will try to predict what is their placement status. Okay, once our model has proved itself on the testing data, then only it will be used for the new data for which right now the Y is unknown and we are trying to predict it. Okay, so classification. In classification, what happens is we have a categorical variable as the target. And there are lots and lots of popular classification algorithms. One of them is linear classifiers. So we'll try to cover logistic regression as one of them. We have support vector machines, decision trees, KNN, random forest. So there are lots and lots of popular classification algorithms. In regression, what do is we try to uh, predict a continuous variable, and more details on regression will be covered when we do linear regression. Now we have something called as univariate and multivariate models. So we saw it here. Here we had lots and lots of features on which my target was depending. So there are multiple independent attributes here on which my target depends. When you have multiple independent attributes, it is called a multivariate model. So for example, here also you see your income is dependent on your education, personality, experience and age. So Y is dependent on multiple independent attributes or features. So it's called a multivariate model. Multivariate model means your model is dependent on multiple independent variables. Your target is dependent on multiple independent variables. Whereas in univariate, what happens is your Y will only depend on one of your feature. So here your X contains only one feature, here your X will have multiple independent features. Okay. Now, let's talk about unsupervised learning algorithms. Let me put it here. Unsupervised learning algorithm. In supervised, we were working with label data. Here, we will not be working with labeled data. We will be working with unlabeled data. What does unlabeled data means? Here we have multiple features, x1, x2, x3, x4, x5. We don't have a target as such. We don't have any target which we are trying to predict. So we have attributes, and now based on this, we are trying to do something. For example, let's say we are trying to group. Let's say we have students. In the same example, let's say we had students, we know their serial number, name, 10th marks, 12th marks, employability test percentage, CGPA, communication skills, interpersonal skills, and maybe even their salary also. But here we are not trying to predict the salary. We have all these attributes and we are not trying to predict anything, but we just have these attributes, and let's say based on these all attributes, we are trying to divide or group the data into 3 or 4 categories, into 3 or 4 clusters. So let's say we have x1, x2, x3, x4 and x5 as the attributes that x1, x2, x3, x4, x5 as the attributes, and then these we have the details of all the students. We have their x1, x2, x3, x4, x5. Now what we are trying to do is we are trying to divide them into 3 batches, because obviously there let's say there are 200 students and we can't teach all of them together. So what we are trying to do is we are trying to put similar students in one batch and dissimilar students in 2 different batch. So we are trying to divide 200 students into 3 batches, or you can say 3 clusters, or 3 clusters, and similar people will be in the same batch, dissimilar people will be in different batch. So based on all these attributes, we are trying to figure out similar people and put them in one batch, and we are making 3 batches in total. You can make 4 batches also, 5 batches also, it's totally up to you. So this is an example of unsupervised learning where you don't have a why, you don't have a target that you want to predict. You're just trying to group some things, or you're trying to perform some tasks, but it does not involve any prediction. So that's what unsupervised learning is. So working with unlabeled data. So for example, you have these 5 cartoons and you do unsupervised learning and divide it into 2 groups. You can divide it into 3 groups also, 4 groups also. It's totally up to you. Now there are different unsupervised learning algorithms. Okay, there are many. We will be discussing a few. The first one that we'll discuss is clustering, which is something very similar to what I already explained. Then we have principal component analysis. I'll explain this also. in brief, and we'll touch base on what association rule mining is. So we'll touch base on these three. We'll cover a few of them in detail in the coming classes, but right now we'll understand what each of them essentially means. So in today's class, we are trying to understand what are these machine learning jargons. When someone says supervised learning, or someone says classification, someone says regression, you should know what these mean. You should not feel that, hey, I don't know these things. So that's why we are setting our foundation right so that we can build upon this. Okay. So first thing is clustering. Clustering is something very, very similar to what we discussed. So basically we have, let's say, around 1,000 students or 10,000 students, and I can't teach 10,000 students together. I want to divide them into 3 batches. So basically I'm going to make 3 clusters, and students will be made to go in one cluster depending on the attributes. So basically I know the x1, x2, x3, x4, x5 for all of them, and based on those attributes I'm trying to put similar students in one group and dissimilar students in different group. Now can I say similarity is kind of reverse of distance? It's kind of reverse of distance. So if 2 points are very similar to each other, then the distance between them is less. And if 2 points are very dissimilar from each other, then the distance between them will be more. If we have 1 point only, then the similarity is going to be the maximum. That is, the point is going to have maximum similarity with itself, right? But the distance there is going to be 0. The distance of the point with itself is 0. So similarity and distance can be called as reverse of each other. So when I say 2 points which are similar, they should be in the same group. That is, 2 points which are in the same group, they are similar, and the distance between them should be minimum. So the distance between 2 points in the same group should be minimized or maximized. What do you think? It should be minimized. Since 2 points in the same group are similar, so the distance between them should be minimized. Should be minimized. So intra-cluster distance, that is the distance between 2 points in the same cluster, should be minimized. The next thing is, if we have 2 points in 2 different clusters, since they are different from each other, they are dissimilar. So the distance between them should be high. So the inter-cluster distance, that is the distance between 2 points in 2 different clusters, it should be maximized. So the main principle of clustering is that the intra-cluster distance, the distance between 2 points in the same cluster, it should be minimized, and the inter-cluster distance, that is the distance between 2 points in 2 different clusters, it should be maximized. That's what clustering is. Let's have a look. So clustering or cluster analysis is a machine learning technique which groups the unlabeled data sets. That is, we are making groups or we are making clusters. It is a way of grouping the data points into different clusters consisting of similar data points. So basically, similar points will go in one cluster, dissimilar points will go in 2 different clusters. The objects with the possible similarities remain in the same group, and where there are less similarities or no similarities, they go to 2 different groups. That is, the intra-cluster distance should be minimized and the inter-cluster distance should be maximized. The distance between 2 points in the same cluster should be minimized, and the distance between 2 points in 2 different clusters should be maximized. Now let's move to the next technique, which is association rule mining. So what happens in association rule mining? We have data like this given. So generally association rule mining is used by shop owners or the shop analyst or the market analyst. And here the data set looks like this. That is, we have the transaction ID, and basically in that transaction ID, what are the items bought in a shop or in a mart, or let's say D-Mart or a shopping mart, right? So We have the transaction ID. Obviously, transaction ID is unique for each transaction. So basically, how many items and what items were bought when one billing was done. So this is basically the transaction number for the first billing, that is the transaction ID is 1, and bread, coke and milk were bought. In the second transaction, beer and bread were bought. In the third transaction, we have beer, coke, diaper and milk. In the fourth transaction, we have beer, bread, diaper and milk. In the fifth transaction, we have coke, diaper and milk which are bought. So for different transactions, different items were bought. Obviously, it could be that the same person has these two transactions. That's absolutely fine. We are concerned with the different transactions that happen and what are the items that are bought. Now in association rule mining, what are we trying to do? In association rule mining, we are trying to create some rules like, if let's say a person buys bread, then there are chances that he will buy milk also. If a person buys milk and bread, there are chances he will buy egg also. So we are trying to make some rules like this. So based on the transaction data, I'm trying to come up with rules like these. So basically, if a person has bought some things, then what are the other items that he or she can buy? So these are the association rules that I'm trying to generate. So association rule mining means that find out such association rules, that is, if a person is buying these, then what other items the person can buy. Now, why is this unsupervised learning? This is unsupervised learning because I am not predicting anything. I don't have a target to predict. I don't have labeled data. So that is why it is under the category of unsupervised learning. Now the next question would be, what is the advantage of these association rules? Why do we need these association rules? There should be some application, right? Obviously, the application of clustering was that I want to divide the students into 3 batches so that I can, because I can't control 10,000 students in one batch. It's going to be too much. Many students won't understand. Some students would be fast, some would be slow, some would know something, some won't know anything. So that's why I'm trying to divide it into 3 batches so that I can teach all of them at their pace. So similar students would be in one group. What is the advantage of association rule mining, or why are we actually doing association rule mining? This is going to be very important for the shop or the market. Why? Because let's say in the supermarket, I have only 100 units of bread with me, whereas I have, let's say, only 10 units of milk with me. But since I know that if people come to buy bread, then there's a chance that they can buy milk also. So I can actually order some units of milk, because otherwise I will get shortage of milk, right? So that's why I can order milk, because if people are coming to buy bread, then there are chances that they buy milk also. So I should order some units of milk. The next thing is, if I have kept bread at one place, I can keep milk also at the same place, because if a person comes to take bread, then if he or she sees milk, then they'll buy that also. So I should put these two at a similar place. I can also create combos of bread and milk, that is, put bread and milk as a combo and just have maybe a discount of 1 rupee there, or maybe have some lucky draw, or put some offer essentially. So since people would see that, hey, I obviously am buying, I want bread, but I might need milk also. So they are going to take your combo and it is going to enhance your sales. So as a shop owner, it's very important, as a shop owner or a manager of the shop or anything, it's very important to have those association rules. And the process of getting those association rules is called association rule mining, which is an unsupervised learning algorithm. Hope this makes sense. There's another technique which is principal component analysis in unsupervised learning. I'll probably explain it to you in the next class, because it's very related to dimensionality reduction, and I'll explain that in the next class. Okay. Now we are done with supervised learning introduction. We are done with unsupervised learning introduction as well. The last one that we are left with, which we're just going to touch base and we're not going to deal with it more, in this is reinforcement learning. So in this course, we are just going to understand what reinforcement learning means, not more than that. So in reinforcement learning, we basically have an agent which interacts with the environment. So the agent can do anything in the environment. Based on what it does, it gets rewards or penalties. And it is going to try to maximize its rewards and minimize its penalties. Okay, so in reinforcement learning, what we have is an agent which interacts with the environment. It's trying to maximize its rewards based on whatever it's doing. It will get some rewards or penalties. So it will try to maximize its rewards and minimize its penalties. Let's see. So let's say we have the agent like this. Now in the environment, on one side there is fire and on other side there is water. Now the agent has two options. It can go to the fire side or the water side. Now the agent will think. Now the agent does not know anything, so it will probably just randomly go in one direction. Let's say it goes towards the fire. It goes towards the fire and sees, ouch, I got a penalty. And then it will remember that I have got a penalty because of fire, so I have to avoid it next time. Then let's say it goes towards water and it probably gets plus 20. So it will be happy that I got plus 20 and I have got reward. So whenever there is water, I need to go towards it. So it's going to update its learning policy, and then obviously it's going to keep on updating its policy until it finds a optimal policy. So in reinforcement learning, we have an agent which interacts with the environment, and it receives rewards when it performs something correctly, and it gets penalties when it performs something incorrectly. The agent learns without the intervention of human. So there is a dynamic environment and everything is dynamic. Humans are not intervening. Obviously, we have just said what is the reward, what is the penalty. We have said that. But the agent is going to learn on its own by maximizing its reward and minimizing its penalty. It's kind of a dynamic programming that trains algorithms by the system of rewards and punishments, maximizing rewards and minimizing punishments. Reinforcement learning has lots and lots of applications. Can you think of one of the applications? Have you played chess with a computer? So basically you on one side and computer on the other side. What is that computer essentially? That computer is basically the agent. This is what the agent has learned from reinforcement learning. It has played so many times, it knows what the outcomes are, and it has always updated its policy of playing, and that's how it has become an agent which can probably defeat the humans also. So that's an example, a very good example of reinforcement learning. Now, any online game where we have a computer playing on the other end. Okay. So these were the three different types of machine learning techniques: supervised, unsupervised, and reinforcement. In our course, we are going to focus a lot on supervised and unsupervised learning algorithms. We have discussed what reinforcement learning means. Now, let's talk a bit about data. Obviously, I've told you that the data set consists of objects and attributes. Object is what? Object is basically the record or the row, whereas attribute is called a column or the feature. So an attribute is the property or a characteristic of an object. So basically, for example, serial number, it's the property of the student, right? 10th marks, it's the property of the student. And a collection of attributes describe an object. For example, the serial number, name, 10th marks, 12th marks, employability, test percentage, all of them for a particular student. They consist, that collection is called the object or the record. Now let's see this data. So we have one of the columns as transaction ID, second is refund, third is marital status, fourth is taxable income, and cheat is yes or no. Let's say if cheat is the target attribute, all of these are attributes, right? All the columns are called attributes. And if cheat is the target attribute, then what type of learning algorithm would it need? A classification algorithm or a regression algorithm. Obviously, we are trying to predict the cheat. So it's supervised learning. Since here we have a category to predict which can only be yes or no, it's a classification problem. And all of these rows will be called as objects. Now attributes are of different types. There are 4 different types of attributes: nominal, ordinal, interval, and ratio. I'll explain all of them now. So we understood that the data set is going to consist of rows and columns. And the columns, also called as the attributes, are of 4 types. First is nominal. Second is ordinal. Third is interval. And the fourth is ratio. So what happens in nominal attributes? So basically, for example, if we have the gender. Now, in the gender, there could be only 2 possibilities, male and female, right? So basically, in nominal attributes, we can only figure out if the attribute values are the same or they are not the same. That is, they are equal or not. So here we can only figure about the equality or not equal. So we can figure out that the student 1 and student 2 don't have the same gender, but the student 1 and the student 3 have the same gender. So we can only figure out whether the attribute values, that is whether the 2 attribute values of gender are equal or not. So gender is going to be a nominal attribute, where we can only figure out if the 2 attribute values are same or not the same. That is nominal attribute. Moving on to ordinal attribute. In ordinal attribute, for example, grades. Let's say the first student has grade A, then second B, third also A, fourth has C, the fifth has B. Now here in the attribute values, you can figure out whether the 2 students have the same grade or not, that is the grades are same or not the same, but you can also order the students on the basis of their grades. That is, you know that A grade is better than B grade is better than C grade, and so on. So here not only you can figure out whether the 2 grades are whether the 2 attribute values or the 2 grades of 2 students are the same or not, but you can also figure out which is better and which is not. So here not only you can figure out about the equality and the inequality, but you can also order. Okay, so grades is going to be the ordinal attribute, example of ordinal attribute. Moving on to interval. So in interval, for example, let's say temperature in Celsius. Let's say day 1 has temperature as 4 degrees Celsius, day 2 has 5 degrees Celsius, day 3 has 10 degrees Celsius, day 4 has 12 degrees Celsius, and day 5 has 15 degrees Celsius. Now here you can obviously figure out that the 2 days, that is the 2 attribute values, are same or not the same. In our case, obviously they are not the same. You can also order which is bigger and which is smaller. That is 4 degree is colder and 5 degree is hotter. But you can also here, obviously you can order, you can find out they are equal or not, but you can also do one more thing. That is find out the difference. The difference in the 2 day temperatures is 1 degree Celsius, which is not huge. Here, if you see the temperature difference between 4 and 15 degrees Celsius, that is 11 degrees Celsius, which is huge. So you can also find the difference, and the difference carries a logical meaning. That is, this is very small difference, here this is very large difference. That is, the temperature has changed drastically from day 1 to day 5. Okay, so in interval, what you can do, you can figure out whether the 2 attribute values are equal or not. You can also order them, and you can also find the difference between the 2 attribute values, and this difference is logical. It has logical significance. Now the temperature in interval could be minus 6 degrees Celsius also, right? So in interval, the temperatures or the attribute values can go below 0. Whereas in ratio, everything remains the same. That is, you can figure out whether the 2 attribute values are equal or not. You can order them as well. That is, whether which is bigger, which is smaller, which is hotter, which is colder, and so on. You can find out the difference as well between the two attribute values. And here we have a clear definition of 0. That is, the values cannot go below 0. For example, here we have here let's say we have temperature in Kelvin, 4 Kelvin, 273 Kelvin, 100 Kelvin. So here in ratio attribute, if the temperature in Kelvin is the ratio attribute, because obviously we can figure out that the 2 days don't have the same temperature. We can order them that 273 is greater than 4. We can also find the difference is of 269 Kelvin. And also the temperature in Kelvin cannot go below 0. It cannot go below 0. Right? So let's revise all the 4 attributes once again. Nominal, ordinal, interval, ratio. In nominal, we can only figure out whether the two attribute values are equal or not equal. In ordinal, we can figure out whether the two attribute values are equal or not equal, and you can order them as well. In interval, what you can do, you can figure out the two attribute values are equal or not. You can order them also, and you can find out the difference as well. In ratio, you can find out whether the two attribute values are equal or not equal. You can also find out the order, that is, you can order them as well. And then you can also find out their difference. But one more thing that's there is that you should have a clear definition of 0. That is, the attribute values in ratio cannot go below 0. They cannot go below 0, right? So we have nominal, ordinal, interval, ratio. Let's see a few examples. First, let's understand the difference between interval and ratio. The difference between interval and ratio scales comes from their ability to dip below 0. Interval scale holds no true 0 and can represent values below 0. That is, temperature in Celsius can go below 0, whereas in ratio, it cannot go below 0. Now let's find out the attribute types here. So what is temperature in Kelvin? We already discussed the value cannot go below 0. We can find out whether the two attribute values are same or not. We can order them. We can find the difference. The difference has logical meaning, and the value cannot go below 0. So the temperature in Kelvin is ratio attribute. What about the next one? Temperature in Celsius. So temperature in Celsius, here the attribute types can be equal. The attribute values, we can figure out whether they are equal or not. We can also order them. We can find the difference, but we can have the values, attribute values going below 0. So this is going to be interval attribute. Grades. In grades, we can only figure out whether the attribute values A and B, whether they are same or not the same, and we can order them. A is greater than B. We cannot find the difference. So this is going to be ordinal. Length. This is interesting. Length, we can obviously find out the two lengths are same or not. We can figure out which is big. We can order them, which is bigger, which is smaller. We can also find out the difference. And the fourth thing, length cannot be less than 0. So this is what? It is a ratio attribute. Eye color. So we have black and brown eye color. So here the eye color is black or brown, right? Now eye color, we can only figure out whether the two eye colors are same or not same. Obviously we cannot order them, which is better, which is not. We can also not find the difference. So here it's only nominal. That is whether the two eye colors are the same or not the same. Okay. We'll stop here in this session, and in the next session, we are going to continue with the introduction to machine learning, understand more machine learning jargons. So today we discussed what machine learning is, what are the types of machine learning, what are the applications of machine learning, and we dived a bit into the data set, into the attribute types. One more last thing that I'd like to tell is nominal and ordinal attributes together are called categorical attributes or categorical variables.